Hello, I'm Eric Snodgrass, and thank you for watching today's in-depth ag forecast video brought to you by Nutrien Ag Solutions. Well, just a quick announcement before we get started. This is going to be my last video for 2021. I'm going to take a break between Christmas and New Year's. In fact, my kids would like to go on a trip. They said they wanted to see lake effect snow, so we're going to go see some lake effect snow. Should be a good time. I will pick right back up on January 3rd, the first Monday after the new year, and we'll just go right back into our normal cadence. But I'll finish with this particular year's last video with the story about the relationship between weather and Christmas. And yeah, it has something to do with the fish you've been looking at here. That's an anchovy. And where I want to take you next is here to Peru. So in South America, the country that's right here on the west coast is Peru. And the fishing grounds just off the coast here are some of the best in the world. And you ask why? There's a lot of upwelling in the ocean currents here, bringing a lot of nutrients to the surface. And those anchovies feed on that. And those anchovies are at the base of a food chain, which means everything above them is here feeding as well. Well, Peruvian fishermen play an important role in the story I'm about to tell you, because it turns out that when the ocean temperatures change right off the coast, it drastically affects the fishing. And when they get really, really warm, these fish all leave. The last time that happened was right here, December 25th, 2015. And what you've got in place right here is an El Nino. Now remember, El Ninos are when the water from South America stretching into the Central Pacific are warmer than their climatological average. There's also a trade wind response to this, where the trade winds are often weak or even reversed, going back toward the east from the west. And of course, just like the La Nina we've been discussing now for actually several months, this has an impact on global weather patterns. In fact, the entire globe. It is the largest known atmosphere-ocean circulation pattern. We call that a coupled system that there is on Earth. So thinking about all that, where does the Christmas story come into this? Well, those Peruvian fishermen right here in the late 1890s called this odd kind of timing of the warming up of the water in this area El Nino. That's where it got its name. Now, why did they call it El Nino? What did I mean by odd timing? Well, it turns out that these events don't happen with predictable regularity. When they do occur, we monitor them and see how things change, but the next El Nino or the next La Nina is very difficult to predict beyond about 6 months. But what we do know is that they typically reach a peak, either El Nino or La Nina, around a very important little boy, which is how you translate the word El Nino. And the little boy we're talking about here, we're about to celebrate his birthday in 2 days. And that's right. So this is El Nino in this case, which you should always capitalize El Nino, refers to Jesus. And the reason why the Peruvian fishermen called it that was because the peak of the warming of these waters, or the peak of the cooling of these waters when there's a La Nina, tends to happen right around the end of the year. Now, I can prove this to you. Take a look at this long time series of ocean temperatures out there in the middle of the Pacific Ocean. There's a line in the back of the graph. See them? They're all spaced out here. That's one for every single start of a new year. So see how they're all labeled January. Now, if you notice, the peaks of all these lines, these are the big El Nino events, like the 82-83 event, or the 97-98, or the big one here, 15-16. See how they come right up on one of those grid lines? Well, the grid line begins the new year. It's the same thing with La Nina. The peaks down, you can see them labeled here, represent those big La Nina years. And we just had our second bottoming out of our ocean temperatures across the Pacific Ocean. So right on cue, this La Nina has begun to dissipate. It reached its peak, and now we're starting to see the after effect of that. So I want to show you that by, let's try this. There we go. I want to show you that by looking here at an animation of ocean temperatures going all the way back over the last 90 days. So when this resets here, take a look with me. Ready? Let's let it reset. It'll go right back to, here we go, end of September. Now you see the ocean temperatures through the month of October, and then eventually into November, continue to get cooler and cooler. That was our strengthening La Nina. Here they are in late November, very, very cold. Now watch as we get toward the end of this animation. You can start to see that this region's cooling off, warming back up, while over here next to South America, it's still quite cold. This is just very characteristic of what a La Nina does. And because the thermal inertia of water is about 5 times that of land, we're going to be still dealing with the after effects of this La Nina for the next several months. It's going to take a long time to fade away. And my first videos back in the new year will tell you what the new long range is projecting. But let me show you why this all matters. So going back from October here to early December, right when the La Nina peaked, I would put that peak right around somewhere between the 10th and the 15th. This is the characteristic signature of a La Nina. You ready? Right in through here. the trade winds were much stronger than normal. So this is a wind speed anomaly map. So anything that's color shaded is faster than normal, and the arrows tell you the direction it was going. The Indian Ocean responded likewise, and we had over here winds coming out of the east out of the west heading toward the east. So there was a whole lot of rising motion here, and that was part of the reason why back in November, for example, Australia had such very, very wet weather. All the rising motion was sitting right in this area. Now there's some other pieces to this. Let me show you a different map. This is what was going on way at the top of the troposphere where the jet stream is. So what comes this direction then has to go back in that direction. See it? We had much stronger winds there. But I want to show you what this did to the North Pacific, because throughout much of October, November, and early December, it planted a very large ridge right here. Now why this is so important is that ridge directed the storm systems into British Columbia along the US-Canada border. And the flow came around. I know it's kind of a hard graph to see. The anomalous flow came around like this. So we've had no subtropical branch of the jet stream, which is here. And it's been very dry in the southern plains as a result of that, while all the actions come into the west and run along the US-Canada border. Now watch this. I told you that La Nina is fading. This ridge I'm putting an X in is moving that way to the east. And things are beginning to shift. And one of the reasons why is that during the time period of October, November, and early December, where the trade winds came in like this, and they came easterly toward the east here out of the Indian Ocean, all of the rising motion was there. But these trade winds are backing off. That's normal, which means this rising motion is shifting this direction. And we got a lot of subsidence now happening over the Indian Ocean. We've been discussing this in great detail. That's the shift we're going to get, and I want to explain to you what I expect to see out of it. So do you see this column here of warm colors sitting right over the Indian Ocean? That's where the velocity potentials are positive, meaning the air is sinking. And we can see why. I've shown you these the last couple of weeks here. The trade winds across the Indian Ocean for the next 15 days are strong. They're out of the east going to the west. And now, where we once had those strong trade winds from our La Nina, we have a westerly component to this. So the net effect is that right now where this all splits in this area, there's sinking motion in the atmosphere. And you get kind of a dipole effect, if you will call it that, over here with rising motion in this area. And now what we want to know is how long did these wind patterns in the Central Pacific and Indian Ocean stay like this? Because the European model says, oh, leave it there. Leave it the way it is in phase 7 for a long time. And the reason why it's in phase 7 is because all the sinking motion here. And the new European weeklies, which just came out, let's get an update here. There we go. They are also saying throughout much of January, leave it here. Now this is important. And why it's so important is it ultimately governs what the jet stream is going to do. And I'll take you out here. This is next Tuesday. You see, wherever we get that rising and sinking motion in the MJO region, so Indian Ocean to the Pacific, determines where this is. That's the jet stream coming off of Asia. And at this point, it's only extending this far. And what it's doing is it's splitting here to a large ridge that goes into Alaska, a split piece that goes down toward Hawaii, and then it comes out and rides over a ridge in the midsection of the country. Now what I'm going to show you is that this is going to slowly migrate east with time. But the split is still in place, meaning that our pattern is going to be highly volatile. Now it all comes together into California, comes together in the Intermountain West, and this ridge here, it's going to move east with it. And this is what we just got released. The new January 2022 outlook. Now with deep troughs cutting, in fact, I'm going to show you a different view of this. There we go. See the effect of that ridge? That's putting a large area of subsidence and dry weather there. This is all connected to La Nina and MJO. The flow comes over the top, cuts into the Intermountain West, adding up quite a bit of snowfall here in the mountains. And then what happens is this all ejects, comes out here into the plains, and then takes off into the Tennessee and Ohio Valley, keeping this whole area very active and wet. We also get lots of clipper systems that run along the US-Canada border. Now my biggest concern for the last several months has been this area, because that is an area which we'll take a look at again in a few moments that has shown up dry. It's shown up dry because the flow is not set up to draw that moisture out of the Gulf to return to this region to bring above average precipitation. It would sure help if we could get a subtropical component of the jet stream in there, but it's just not there yet. And since we've looked at the precipitation, let's look at the temperatures real quick. This is what we see. There will at times be kind of a larger protective ridge sitting over sitting down here across the south from Texas all the way over to Georgia. And you're going to see evidence of this very, very soon. But what we end up getting out of this pattern is we end up getting quite a bit of cold air that invades the northern tier of the United States. It certainly sets up over the west and will get into the plains. It will get into the Midwest. It'll get into the Northeast. So our country's going to be split right about there on the temperature pattern. And interestingly enough, that's very characteristic of a La Nina, even a fading one. So I like how this is all coming together. It makes a lot of sense to me. And it's in both models as well. Here's the other one I like to look at. Now we're going to look at the time period January 6th through the 12th from the CFSV2. It is also wet in the west. Clipper systems, active Ohio River Valley storm track, drier in the southern plains. That's a very consistent signal, and it's out there January 13th through the 19th as well, almost the same pattern. So when I see all of this kind of stitched together nicely, it gives me a good idea about what this is going to look like as we all transition out of 2021 and head on into 2022. Now, with the long-range discussion out of the way here, let's go talk about what we've got right now. The month of December so far has continued to be dry for this area, and it's extended here into parts of Missouri. The Mid-Atlantic, getting onto the Carolinas, has also been dry, so you can see clearly where we've had some drier areas. This is my drier concern moving forward. I think we're going to see some corrective action in this area as we go forward. Now, looking at those soil moisture values, we are very dry, down about 16 inches in this area, and it extends here into the western Corn Belt, but I think we're going to see better precipitation here moving forward, and certainly better precipitation here. So my biggest concern is where it is already very dry in that area. And that's a region where when we look at our latest drought monitor, which you're seeing here, we've seen a lot of change when we just look back even over the last week. Take a look. We saw a one-class degradation around the Red River Valley of the south, east south of it, and then getting up here into Kansas, Colorado, parts of Oklahoma. We've stitched that all together, though, over the last 3 months, and this is what you've got. So my concern going into winter is going to be, are we capable of returning moisture to this area? Because we're going to see better moisture here and better moisture here as we go forward. Now from there, let's go talk temperatures, because so far the month of December has been extremely warm. And I know you've all seen the forecast of how warm it's going to be here tomorrow on Friday, because I record this on Thursday night, and then getting into the Christmas weekend. So we're going to finish this month with quite a bit of warm air, but there's a lot of cold air coming into the northern plains. In fact, I think by the time we get to this weekend, we'll see temperatures in the 80s in Texas and the -5 to -10 range here. So the plains are going to have a really wild swing in temperatures. But right away in the near term, I thought we'd talk about snow, because we're going to get into a forecast here. And I kind of made a map, and after I looked at it, it's really kind of ugly, and I'm sorry about that. But what it is here is it's showing you the snowfall departure from normal, but it's got a big blue contour line on it. So you can see in the background with the color shading where we are above average in snowfall through this point in the year and below. In the Sierra Nevadas, there are places in the Sierra Nevadas that have already surpassed all of last year's precipitation, and we still have so much of this wet season to go. Now, when you look at it, though, big sections of the plains getting into the northeast, there's still a lot of places that not only are in snow deficit, but now we come to why I put that blue line on here. Everywhere south of that blue line, we have not measured more than 1/10 of an inch of snow so far this year. In some places, of course, that's 0. And that's very rare to get this far into December and not have snow, especially in this area over in the Appalachian Mountains. Really impressive to see that. Well, as we go forward in this forecast, I told you things were going to start to get active. Now, with the deepening of that trough in the west, the Intermountain West, if you have ski plans over the next 15 days, I've got you set up perfectly here. The problem is as that flow ejects out here into the southern plains, there's going to be a large area that we're unable to tap into the best of moisture, so it stays dry. Where does it come together? Clipper systems rolling through here, and then a big high pressure cell sitting there, all meet to create an active track through the Corn Belt, down here into the Ohio and Tennessee Valley, all the way down to the lower Mississippi River Valley. And this all comes together into the northeast. That temperature pattern, though, take a look at this. Next 10 days on average, a lot of this is driven by the next 4 days. Very, very warm in this area. But we're off my color bar again. That's more than 20 degrees above average. But the split across North America is tremendous, and this cold air is here, and we're going to see a lot more of this getting into January, coming out across the Midwest and into the Northeast. So right now, our all hazards weather map. In fact, let's get an update on that. There we go. We still have a lot of very colorful map here in the west. A lot of this is winter weather advisory, winter storm warning, all of that associated with those deep troughs. There's even a flood warning down here in Southern California. But as you get out into the plains, this is all wind. And this is red flag down here. And that's it, right. We're going to have another really windy go of it. From now through Saturday evening, this is a map just showing you across the country maximum accumulated wind gusts. And that's right, in parts of New Mexico, getting out here to Oklahoma, Kansas, Missouri, we could have winds gusting once again in that 40 to 60 mile an hour range and much higher coming off the mountains in New Mexico. So again, we're going back over to very windy conditions on extremely dry soils, which is why we got that fire threat back in place. But this is what the jet stream's doing. Big split flow, remember talking about that, comes together here and then just runs up over a ridge right in that area. Now, as this pattern begins to evolve, watch how it's going to change. So now you can see it. There's the ridge, the big split in the ridge. Sorry, let's get there. And here's the trough, and there's the ridge that's over the midsection of the country. Now I'm going to play this quickly, getting through Friday and then into Saturday. What I want you to watch is coming over this ridge, the flow does something like this, and we just keep ejecting little short waves here. Those are our clippers. There's the first one on Saturday. So watch it. Clips out, goes right over there into New England. Then another one shows up right there on Monday. And then we get another one coming out right here next Thursday. But this whole time period, what we continue to see is ridging here, troughing in the west, and a ridge over the southeast. And what I want to tell you is what that ends up doing to the precipitation. And to get the answer to that, let's go to our multi-model analysis. So I've got the GFS 12Z on the right, or excuse me, on the left, ECMWF on the right. As we play this forward, look at how active the west is just getting through Friday. We do see that by noon on Friday, as the snow piles up here in the Central Rockies, the Sierra Nevadas, and the Cascades, look at how deep that low is. It's in both models here. There's a clipper that kind of ejects. Remember the first one? It comes right up here toward Lake Winnipeg. We could get some scattered showers in through parts of the upper Midwest and through here. But as that pulls forward, that then spreads into the eastern Great Lakes, and we could get some showers on Saturday, stretching back along the cold front here. Not looking at a lot of precipitation, but there's a chance. Now, after that goes through, let's get on through Saturday. See our next clipper. Whoops, let me take you back there. There's by Saturday evening, another one kind of shooting out there. These are those little short waves coming out. And then we get into Sunday, and here comes the next one. Both models pick up on that. So you see it's bringing a lot of snow from the Red River Valley of the North through Minnesota, northern Wisconsin, Michigan, but there's just too much mild air to bring that snow farther to the south, hence the wetter conditions you see here moving through this part of the Midwest. But the West continues to take these systems on early next week. Now, once we get out there past Monday into Tuesday, there's a little bit different pattern taking over here. And I'm going to draw it for you over on the GFS side. It's this ridge right here, this high pressure cell. You see the flow's going around like that, while little systems keep rolling up like this, which means they come through and drag a front, but they're met with strong southerly winds right here. So the net effect is a lot of frontogenesis, or lift, right in between the two. So as I go from next Tuesday all the way through Wednesday, getting into Thursday, and Friday. Did you see it there? I'll just rock back and forth midweek, Tuesday through Thursday. In both models, this area opens up to wetter weather. We're yet to get it to come back into the high and southern plains, but that's what we see getting out there to about a week from now. And that front clears out, but just notice, both models bring in another active go of it right here. That seems to be where we're stuck all the way to the end of this year. But take note of this. Now, this is an operational run, so we're not going to count on this. But there's going to be a lot more colder air coming in to start the new year, and hence we could get that snow line a little bit farther to the south. But let's stitch together what we do know. As we play forward here through the weekend, there's Friday into Saturday. I'm just going to stop this. How about right there? This map shows you from now until 6 a.m. on Sunday who's got a chance of picking up some more snowfall. Of course, in the west, we're talking about feet of snow in the Sierra Nevada and up to 24 inches in parts of the Central Rockies and Colorado. But other than that, it's going to be here in the northern plains, Canadian Prairie, up into parts of Ontario, and then stretching into the New England area. But going into next week, we saw several little clippers. Remember them coming off of that bigger, deeper wave in the west? There's the first one, and then there's another one. And if I just let this go all the way out here to, next Friday, the 31st or New Year's Eve, this is going to be the area that we're going to be seeing the most snow. So that's where I'm going to go and check it all out, because I really miss seeing snow where I live down here in Illinois. So that's it on the snowfall side of it. Let's now add up all that precip and just see what we've got. So playing through the weekend, there's total precipitation by 6 p.m. on Saturday. So a lot of lighter precipitation through the midsection of the country, a little bit heavier here around the eastern Great Lakes, but not much. We're talking generally under a half inch. As we then play into next week and those clippers come out, now look, I'll just kind of go back and forth. Monday, Tuesday, Wednesday. Can you see the flow around the ridge? Watch right here. That's what we're talking about, and that's going to help fuel more rain into this area. So that's why that region going into the end of this year and the beginning of next is going to be very active. But what about that longer range, 2-week outlook? Well, if we just start here on December 30th and we keep this going forward into January 1st, 2nd, 3rd, and 4th, what we continue to notice is that the long-range models want to keep this ridge in place here. It's a little further east now. The trough is coming into the Intermountain West, but it's ejecting quickly over a subtropical ridge here. So what we end up getting out of that pattern is this: snowy and cold in the west. Systems pop out here, and that's where we tend to see the above average precipitation into week 2. It's in both models, so I really like the agreement here. That gets you to January 6th. Let's talk temperatures now. Okay, today was very warm across the plains, and watch this. This is the temperatures on Christmas Eve and then into Christmas Day. But you can already see the really cold air coming in here into the northern plains. So 83 to 5. That's what our temperature difference is, and it gets worse on Sunday and into Monday. So we now have high temperatures in the negative single digits here, which is much below average, while we're still in the 70s in the Mid-South. And that's going to continue as we go forward into Tuesday, Wednesday, and Thursday. But that cold air tries to advance. But when we look out there just on day 5 through 10, let's shrink this up and get a good look here. The stronghold where that ridge is down here. But that colder air tries to advance into the plains and Midwest, and we'll get let out at times into the eastern part of North America. But very cold air still in place here. And the longer range, looking at day 10 through 15, has it there as well. So in effect, there is a trough here, a deep one. And I want to talk about that to finish this up. Because right now, the polar vortex is here. It's north and east of Greenland and north of Scandinavia. Big, powerful circulation. And the polar vortex right now is strong. It's above the climatological average, which is right in through here. And if you take a look, this line right here tells you the forecast. So you can see it's mostly above average. But I've got some questions about that getting into the month of January. And my questions come from this. So the polar vortex is here right now. What I want you to see is as we play this forward, getting through the weekend and into early next week, first thing we notice is the stratospheric polar vortex, which is this lobe you see right here, is sitting on top of the tropospheric polar vortex. It is not disturbed. They're just co-located in the atmosphere. What I'm starting to see, though, is as we get out here a little farther, this is now the beginning of January. I want to know if the models have this right, pushing a ridge here and a ridge over Scandinavia, because that could stretch that polar vortex and start to get a disruption. And the moment it gets disrupted, we begin counting down the days to where somewhere in the northern hemisphere gets an extreme colder outbreak. I think we're going to be talking a lot about that in the new year. Well, I'm going to wrap it up here. Everybody have a safe holiday season here, and I will talk to you again after we start the new year. Thank you.